Back in the 1930s, an anomalous and highly unusual clay vessel was finally pulled from the ancient dirt in Mesopotamia. The discovery occurred near modern-day Baghdad, at the archaeological site of Kujut, Rabu. German archaeologist Wilhelm König led the excavation, digging deep into the stratigraphy of the Parthian era to uncover the settlement's remains. König found a simple 5-inch terracotta clay vessel. On its own, clay is a standard, non-conductive housing material used universally in the ancient world. But inside this specific pot sat a 1-inch copper cylinder and a 1.5-inch wrought iron rod, held firmly in place by a plug of baked asphalt, or bitumen. Chemical analysis of the interior revealed traces of an organic residue. This indicated the vessel once held an acidic liquid, like fermented wine or palm oil, which would have pooled directly between the two metals. Bronze and Iron Age pottery was designed for basic agricultural storage. A hermetically sealed container holding specific reactive metals suspended in acid defies standard ancient construction, pointing toward a deliberate mechanical function. The creators of this artifact were the Parthians, whose empire ruled the region from 247 BCE to 224 CE. Their territories stretched across modern-day Iran and Iraq, acting as a massive cultural melting pot and trade hub that bordered Rome, Greece, and ancient India. They engineered complex irrigation systems to manage arid landscapes and constructed monumental architecture featuring enormous vaulted arches. Under rulers like King Mithridates I, the Parthians also developed advanced metallurgical techniques, minting highly refined silver and copper coinage. If any ancient civilization possessed the cross-pollinated intellectual framework to accidentally or deliberately harness electrochemistry, it was the Parthians. They possessed the raw material science capability and the geographic resources necessary to construct a functioning power source. To understand what this device is capable of, we have to look at the strict physical thresholds required to generate electricity. The arrangement inside the artifact matches a galvanic cell. A galvanic cell is a system where two dissimilar metals, submerged in an acidic electrolyte, naturally generate an electrical current. In this system, the heavily oxidized wrought iron rod acts as the anode. The iron reacts with the acid and releases electrons into the solution. This specific chemical reaction is called oxidation. Those free electrons then migrate toward the copper cylinder, which acts as the cathode, drawing the particles in. As the copper absorbs the electrons, it triggers a reduction reaction. This differential in potential between the iron and the copper generates a predictable electromotive force. In this configuration, it yields between 0.5 to 1.0 volts. The physical shape of the artifact is secondary to its chemistry. Its exact atomic structure mechanically forces the generation of an electrical current. Modern researchers have rigorously tested these capabilities to see if the artifact functions in practice. In 1977, researcher Walter W. Schnurr built exact replicas using matching terracotta and precise metal alloys. By introducing ancient acidic equivalents like palm oil and vinegar, he successfully triggered the redox reactions between the metals. This chart shows chronoamperometry data from these replications. Chronoamperometry is an electrochemical technique used to measure the stability of a current by monitoring its flow over a set period of time. The data proves the replicas sustained stable electrical currents in the microamp range. This measurable output led to the electroplating hypothesis, the theory that ancient craftsmen used this current to transfer metal ions, specifically to plate thin layers of gold onto silver. Archaeologists have found ancient gold-plated artifacts from neighboring regions, like Egypt and Parthia, that could theoretically have been manufactured using this exact process. Modern physics proves the device functions perfectly as a power source. On a purely mechanical level, the capability model is scientifically undeniable. If you have one functioning cell, you can scale it. Wiring multiple ancient cells together in a series circuit would multiply the total voltage output. A massive array of these clay pots could theoretically power industrial-scale metallurgical processes, like electric smelting, to extract pure metals from ore. Harnessing this power would have allowed ancient manufacturing to scale, replacing the hit-and-miss heat of forge fires with the precise control of invisible chemistry. The battery theory offers a tantalizing, almost futuristic vision of a highly advanced, electrified ancient industrial network. But to determine if this actually happened, we have to look away from pristine laboratory chemistry and go back to the raw, messy reality of the Kujut Rabu archaeological trench. There is a fatal flaw in the battery theory. A power source is absolutely useless without a complete circuit to draw the current. If you connect a load to the device without a broader conductive network, the energy has nowhere to go. There is an absolute absence of conductive wiring, receiving terminals, or interconnected networks anywhere in the excavated Parthian strata. Proponents of the battery theory often point to preservation bias, the idea that ancient copper wires may have simply corroded away in the soil or been looted over the intervening centuries. However, the total absence of any macro-archaeological infrastructure, combined with zero textual records mentioning electricity or electroplating, makes an electrified society highly suspect. This is the cognitive bias of modernity. Because we recognize an anode and cathode today, we retroactively project our modern technological assumptions onto ancient dirt. Applying Occam's razor gives us historically contiguous alternatives. The first is that the pot was a highly effective, hermetically sealed storage vessel for sacred texts. The specific combination of a clay housing, copper and iron inserts, and a thick asphalt seal creates a perfect barrier against the harsh, destructive moisture of the Mesopotamian climate. The second, more culturally embedded theory suggests the Baghdad Battery was a ritually significant talisman or amulet. In Mesopotamian mythology, copper is heavily associated with the goddess Ishtar, representing concepts of fertility and protection. The iron rod, on the other hand, is linked to the god Marduk, historically associated with war, strength, and the cosmos. This aligns with sympathetic magic, the ritual belief that objects can exert physical influence over each other through symbolic resemblance. Binding these two distinct divine metals together in a sealed vessel invoked supernatural power, not electrical engineering. The physical proof of electrochemistry is real, but it must be weighed against the overwhelming archaeological plausibility of ritual and storage. The Baghdad Battery is a monument to materials science capability. It held dormant potential energy for 2 millennia, waiting for a civilization with the specific technical worldview to finally plug it in.